dealing with challenging trig functions and the derivatives of those puppies. All right, what you want to do is you don't want to get intimidated. You need to see most new problems as newer versions of older problems, that we're doing the same old stuff with calculus. We might be using ultimately the chain rule, the product rule, whatever, but we might need to do some trig simplification or use a trig identity or whatever, but the problems are doable. If you get stuck on a test or something, move on, come back to it later. But we have to see these problems as part of bigger, similar problems and not get intimidated by them. And we learn advanced math by making those connections to the bigger ideas, not getting blown away and seeing things as just one version of another problem we've already done. So if I had to say what are the steps for solving these things, can you simplify? Good. So simplify. Simplify some more. Simplify more, and then in the end, if you can't do any more, then go to the product rule, the chain rule, the power rule, whatever. So, we start out with this one, and we need to find the first derivative. That puppy looks intimidating, but we're brave. We're not intimidated. We go in there and we say, I see that they all have the same angle. They all have 3x. That's good news. We probably aren't going to use a double angle substitution because we like the fact that all the angles are the same. We're seeing some cosine squared action like that, so we're thinking maybe the Pythagorean idea, I don't know, but let's deal with this guy. We go in here and we say, aha, I recognize that. 1 plus cotangent squared. That we can replace with cosecant squared. Cosecant squared of the angle right there. And once we do that, we found the key, we found our ticket. Here's what we can do. We can rewrite this guy like this. And then we realize that this is just the inverse of sine squared of 3x. Then we can cancel this thing squared with 2 of those puppies and leave it like that. That brings us down to this, and anytime you have the sine squared of an angle plus the cosine squared of the same angle, that's the Pythagorean identity. That thing equals 1, and the derivative of any constant is 0. So a very intimidating problem becomes one of the easiest problems of all. Then we look at this, find the derivative of this. Now what makes this difficult, guys, is the way that these things are published. We tend to write this as cosine to the 5th of this function right here. That can be a little bit misleading. I think it's a good idea to say what we're doing is we're taking the cosine of this angle and we're raising all that to the 5th power. Even though it's not written that way, you should think of it that way or literally rewrite it this way. And then what do we have? We can't really simplify it anymore, but what we have is the function of a function of a function, and when you have to take the derivative in that situation, it's the chain rule. So we're going to make a u substitution. We're going to start with the innermost function, that u is equal to 4x minus pi. By the way, don't forget, pi is a number, it's a constant. That's going to be an easy thing to deal with. Then we go outward from there. The next function would be the cosine. So we're going to say that v is the cosine of that angle, which we defined as u. So we're going to define v in terms of u. It's the cosine of u. Now we're ready to go right to the y function because we just have the function of a function of a function. So we've already used 2 different substitutions. So we're ready for the third one, which is just y. So we're good to go. We say that y is equal to v, this thing, to the 5th power. So we're going to say that y is equal to v to the 5th. And the chain rule just says, take the derivative of each of these guys with respect to the variable that they're being defined by. So the derivative of y with respect to v is 5v to the 4th power. The derivative of v with respect to u, well, the derivative of cosine is negative sine, so this is going to be negative sine of u. And then the derivative of u with respect to x, the derivative of all that, is just 4. So we got it. We got the chain. We got the chain. It rules. So all we have to do is let's multiply the coefficients together. We got a 4, we have a negative, we have a 5. That's negative 20. So we have that the derivative of y with respect to x is going to be negative 20. Maybe it might be good to take this function next. So this is going to be the sine of u. So times the sine of u, and if you want, let's take 2 steps to get all this down. That's fine. So we have this times this guy, and then finally times this guy, which is 5. Now v to the, I'm sorry, I already took care of the 5. Look at me, so sorry. So it's v to the 4th power, and so we know that v is really, what do we say, the cosine of u. So we could make that substitution. So we got the cosine of u going right there. And now let's crank all this together. And that, by the way, that's to the 4th power. So sorry. Okay, now we can finalize this bad boy up. So we're going to say that our derivative is equal to negative 20 times the sine of u, and u is that 4x minus pi. So we have 4x minus pi. Then we're going to multiply that by cosine. If we want to impress our friends, we'll write it like publishers would write it. And this also is then 4x minus pi. So there we go. That's what the derivative is. So just a step at a time. Don't lose sight. Have a plan, follow it, and it's really very doable. All right, then we take this one. Now, we have a problem here. Those are different angles. You have to be on the lookout for that. When you see that you have 2 different angles, that's bad news. That's no good. So we should be thinking, how can we come up with the same angle? Well, if one angle is double what the other one is, then we're thinking double angle for sine or double angle for cosine. Obviously, this one is for sine. So we can replace that with its equivalent, which is 2 times the sine of x times the cosine of x. And that then can get multiplied by the sine of x. So there we go. There's our function. We made one substitution. We can simplify it some more. We can see that y is equal to, we got the sine of x times the sine of x. So that's sine squared of x. We have the 2 as the coefficient in front, and we have the cosine of x over here. Now we have options. We can stop and say, okay, I don't know if, do I want to simplify some more? Right now we have the product rule. We could have this function times this function. But you know, anytime we see sine squared of x or cosine squared of x, we might be thinking, hey, make a substitution. I don't know, just because I could get everything down to just the cosine of x and avoid the product rule, I think I'd probably want to make another substitution here. I'm going to go ahead and replace this guy with 1 minus cosine squared of x. So I'm going to have this times 2 times the cosine of x. And so here we go. We're going to have y is equal to, if we take 1 times this and then times the 2, we're going to end up with 2 cosine of x and then minus 2 times cosine squared times cosine. If you need to take another step in there, maybe that was bad of me to do all this in one shot. But if you multiply that out, maybe this binomial times that, and then by the 2, you're going to end up with this in the end. So now what's nice about this is I don't have to use the product rule. I can just take the derivative of this term and the derivative of this term. So away we go. Let's extend this a little bit. We can say that the derivative of y with respect to x is equal to, well, the cosine, that becomes negative sine, so it's going to be negative 2 sine of x. Then we can go over here, and we know that we're going to do the chain rule. It's the cube of cosine. So I think we can do this in one shot. We can bring the 3 in front, make this negative 6, times cosine squared of x, then multiply it by the derivative of cosine, which is negative sine of x. So in the end, what we have is the derivative of y with respect to x is going to be negative 2 sine of x plus 6 cosine squared x sine x. And that's good enough. We can leave that bad boy like that. So again, it's all doable. Then we get to this. We got to be careful. Sometimes we lose sight of the simple things in mathematics. When you square a binomial, you're going to get a third term. So don't be thinking that this whole thing equals 1. Be careful and multiply it out. So what you're going to get is y equals the sine squared of x plus 2 sine of x cosine of x, and then plus cosine squared of x. Now this is pretty cool, because if we think about this, when we combine this guy plus this guy, we know what we're going to get. That gives us 1. So we could say, okay, we got y is equal to 1 plus, now we got 2 sine of x cosine of x. I don't feel like doing the product rule. So I realize that that's part of the double angle for sine. So I can replace this guy with sine of 2x. So there we go. There's our function. We simplified it. That's a lot simpler. We didn't get duped by forgetting that there's going to be a middle term. And now we take the derivative. So we can say, oh, let's use another color because it's fun. We can say dy dx is equal to, well, the derivative of a constant is 0, so that goes bye-bye. And then again, this would be a chain rule, because we're taking the sine function of this sine function. And just for giggles, we don't necessarily have to do this. I think we could do it without a use substitution. But let's go ahead and model good behavior. U is equal to 2 of x. And then we could say that v is equal to the sine of u. And so we could say this derivative is going to be the cosine of u. So this will be the cosine of u. The derivative of that is going to be 2, so we multiply that by 2, and we recognize that u is the 2x, so in the end what we have here is the cosine of 2x multiplied by 2. We can put the 2 in front, so there we go. The derivative of y with respect to x is equal to that puppy right there. I think that's all I had. Yeah, so there we go. So that's all we got to do. Don't panic, just look at stuff. There's substitutions you can make. Try to simplify things down as much as possible. Use good math, think things through, be careful, and calculus involving trig functions is very doable.